for entrance exam, remember, if A is a diagonal matrix, then A inverse equal to, only take the x, instead of x 1 upon x, instead of y 1 upon y, instead of z 1 upon z, means reverse the number only, you get the inverse of diagonal matrix. Again we discuss very interesting problem. A equal to given matrix 1 2 3 4 and capital X is 2 by 2 matrix such that given condition is A into X equal to I, and find X. So we start the solution. What given condition? We start with a given condition A into X equal to I. So given A into X equal to I, X equal to I, therefore X equal to what? This A goes to the right hand side, become A inverse, into this identity matrix I. But I consider this I identity matrix means consider 1. Identity means 1, or unit matrix, or unit means 1. So 1 into A inverse. So capital X equal to A inverse. So we want to find X, means we want to find A inverse. So we can find the A inverse of this given matrix A by using inverse method or adjoint method. Also we use the row transformation method, but always we use the adjoint method because this method is very easy. Okay, so what is the formula for A inverse by adjoint method? So formula is A inverse equal to 1 upon determinant of A into adjoint of A. So what condition on this determinant A? Condition is determinant A is not equal to 0. If determinant is 0, then what happen? 1 upon 0, infinity, any number upon 0 always in infinity. So 0 into this adjoint means infinity into this adjoint is infinity, and therefore A inverse not exist, and therefore condition is that determinant A is not equal to 0. Determinant A is not equal to 0. So first we find the determinant of A. So therefore determinant of A equal to, what is our A? We take the determinant of this matrix A. So determinant of matrix, first row 1 2, second row 3 4, and what is the determinant? This is a 2 by 2 determinant, 2 rows and 2 columns, and therefore this number 1 into number 4, 1 into 4 4, minus this number 2 into this number 3, 2 into 3 6, 4 minus 6 equal to minus 2, and therefore determinant A is not equal to 0, and therefore A inverse exists. A inverse exists. Again we find the adjoint of A. So here given matrix A, for the adjoint of A there are 3 steps. First step is we want to find the minor of given matrix. Second, we want to find cofactors of given matrix, and last we want to find transpose of cofactor matrix, means adjoint of A. So first we find minor of minor of matrix A equal to, so what is the minor? Minor is nothing but minor of number is the determinant obtained by deleting row and column passing through that number. So what is the minor of this number 1? Delete a row and column passing through that number and take the determinant of remaining number. Here is the what remaining number? 4. So determinant of 4 what? Again 4. Again determinant of this minor, we want to find minor of this 2. So delete row, delete column, what remaining? 3. Determinant of 3 what? That number itself, because determinant of first order determinant, expansion of first order determinant means that number itself. So what is the minor of these 3? So delete row and column passing through this number 3. So what remaining? 2. Determinant of 2 itself 2. What is the minor of now last number 4? Delete row and column passing through this number. So what remaining? 1. Determinant of 1 itself what? 1. So this is our minor matrix of matrix A. We want to find a cofactor matrix. So cofactor or cofactors of A only what? What is cofactors of A? Here is a 4, 3, 2, 1 and this is a 2 by 2 matrix. So what our idea? Diagonal numbers are no change, only here is a change by sign. So what happened? 4, 1 as it is, only change by sign, means here is a plus 3, so we do minus 3. Here is a plus 2, so we take minus 2. So this is a cofactor of given matrix A. So what is adjoint? Adjoint of A equal to transpose of this cofactor matrix of A. So first row 4 minus 3, second row minus 2 1 and it's a transpose. Transpose means convert the row into column, So first row become first column. So first column is 4 minus 3. Second row become second column. So second column is minus 2 and 1. So this is our adjoint of A. By putting this value of adjoint of A in the formula, we get A inverse equal to 1 upon determinant A. What is determinant A? Minus 2. So 1 upon determinant A is minus 2 into adjoint of A. What is the adjoint of A? This is a matrix. So 4 minus 2 and last row minus 3 1 minus 3 1. So we have find the A inverse of a given matrix and we finish this problem. So we enjoy also more problems. We enjoy all more problems on the matrices. So this is also very interesting problem. Find matrix capital X such that Ax equal to B where A and B is given. So we start the solution. So here is a what given condition? Find matrix X such that equal to B. A into X equal to B. So given condition is Ax equal to B. Ax equal to B. Therefore, what X? X equal to this A goes to the right hand side, become A inverse, become A inverse into this B as it is. So for finding capital X, we want to find A inverse because in our hand B as it is, here is a B, but we want to find this A inverse. For finding A inverse, what is the procedure? We use the method of adjoint method. We use the adjoint method. For adjoint method, what is the formula? For adjoint method, what is the formula? So formula is A inverse equal to 1 upon determinant A into adjoint of A. Adjoint of A. Here is a what condition? Determinant A is not equal to 0. Determinant A is not equal to 0. So first we find the determinant of a given matrix A. So therefore determinant A equal to, so we find the determinant of this matrix. So determinant notation is 2 vertical bar. So first row 1, 2, second row -1, 3, and this is a 2 by 2 row, second order determinant. This is first row, second row, this is first column, second column. So how expand this? This first number 1 into this number 3, we take cross multiplication. 1 into 3, 3 minus 2 into -1 means again -2. 2 into -1 means -2, and minus plus 3 plus 2. 3 plus 2. So what is the value of 3 plus 2? Equal to 5. Equal to 5. What's the main step? 5, which is not equal to 0. Which is not equal to 0, and therefore A inverse exists. A inverse exists. After that we find the adjoint of A. So 3 steps required for finding adjoint of A. First step, finding the minor of matrix. Second, finding the cofactors of matrix, and last, transpose of cofactor matrix means adjoint of A. So first we find the minor matrix. So minor of matrix A equal to minor of matrix A equal to means minor of numbers of given matrix A. So how minor is find? So here is a given matrix A. Minor is nothing but determinant obtained by deleting column and row passing through that number. So here 1, we delete row and column passing through this number 1. So what remaining? 3. So we take the determinant of 3. Determinant of 3 means 3 is a determinant of 3 is the first order determinant. So first order determinant is expanded by its number itself. So determinant of 3 is itself 3. Again, minor of 2 what? Row, column delete, what remaining? Minus 1. Determinant of minus 1 itself. Determinant of minus 1 itself. Next, what is the minor of minus 1? So, row, column delete. So, what remaining? 2. So, what is the determinant of 2? Again, 2 itself. Minor of 3. So, delete row and column passing through this number 3. What remaining? 1. So, determinant of 1 itself 1. So, this is our minor of matrix A. We find also cofactors of matrix A, means cofactors of A equal to what? What is the cofactors? This is a 2 by 2 matrix. For 2 by 2 matrix, what is the idea? For finding the cofactors, no change, no change. And here is this is diagonal numbers, no change in the diagonal numbers, and change in the diagonal numbers by only sign. So 3 1 as it is, this minus 1 become plus 1, and this 2 become minus 2. So what is cofactors of A? 3 1 minus 2 and 1. So therefore adjoint of A. What is adjoint of A? Adjoint of A. What is adjoint of A? Adjoint of A is nothing but transpose of cofactors of A. Means this matrix is the cofactors of A, and we take the transpose of this matrix. So 3 1 and this minus 2 1. Minus 2 1. It's a transpose. Equal to, transpose means what? Transpose means row converted into column. So first row 3 1 converted into first column 3 1. Second row converted into second column. So what? Minus 2 1. This is a adjoint of A. Adjoint of A, and therefore by putting this value of adjoint of A and value of determinant A equal to 5 in the formula, in this formula we give the number 1 to this formula, and we find the A inverse. So therefore A inverse equal to what? 1 upon determinant A. Determinant A is here 5. So 1 upon 5 into adjoint of A. What is the adjoint of A? Here is 3. First row 3 minus 2. Second row 1 1. So this is A inverse. We have completed the first problem. Also we discussed the second problem. Very interesting. What problem? A and B is a given, and verify AB inverse equal to B inverse into A inverse. So we discussed the second problem. So solution start with LHS. What is our LHS? LHS is AB inverse. LHS is AB inverse. So how the AB inverse prepare? This is A, this is B, A into B. So first we find A into B and then find its inverse. Then find its inverse. So equal to, as it is. So we write for A, the matrix A. What is the matrix A? 2 3 1 2 2 3 1 2 1 2 into B. B means this matrix 1 0, second row 3 1, first row 1 0, second row 3 1. A into B this, and it's a inverse. It's inverse. So how can find the product of two matrix? So simple idea. First row, first column, sum of product of corresponding numbers. First row, first column. So sum of product of corresponding numbers of rows and columns. So we take first row, first column. So 2 into 1 2. Sum means plus. First row, first column. 2 into 1 2 plus 3 into 3 9. So first row, first column, finish. Again use first row, second column. पहला रो प्रिपेयर करने के लिए पहला रो ऑल कॉलम्स ऐसा यूज करना है. सो 2 into 0 0 प्लस 3 into 1 3. अगेन सेकंड रो, फर्स्ट कॉलम. सेकंड रो प्रिपेयर करने के लिए सेकंड रो, फर्स्ट कॉलम, सेकंड रो, सेकंड कॉलम. बट प्लेस टू प्लेस मल्टीप्लीकेशन लेना है और बाद में सम. मीन्स दिस इज फर्स्ट नंबर ऑफ सेकंड रो एंड दिस इज द फर्स्ट नंबर ऑफ फर्स्ट कॉलम. सो 1 into 1 1 plus 2 is the second number of second row and 3 is the second number of first column. So 2 into 3 6. So here is the first row, first column, finish. Again first row, second column. Similarly first number of second row into first number of second column. So 1 into 0 0 plus 2 into 2 is the second number of second row and 1 is the second number of second column. So 2 into 1 2. So multiplication take place place to place, but with addition. With addition it's a inverse as it is, equal to what? 2 plus 9 11, 0 plus 3 3, 1 plus 6 7 and 0 plus 2 2. It's a inverse. So we find the also inverse of this matrix, then complete our LHS. Complete our LHS. यहाँ पे अब A इनवर्स हमने निकाला है और हमें फाइंड करना है कैपिटल X इक्वल टू A इनवर्स इनटू B. So we put the value of the A inverse in this place. So what we get? Capital X equal to what is A inverse? This matrix. So 1 upon 5 matrix 3 minus 2 second row 1 1 into B. Into B. What is B? Here is a B is a matrix 0 1 2 4. So first row 0 1, second row 2 4. So what is the multiplication of two matrices? Sometimes what happen, some students make the multiplication of this matrix by this number and then take the multiplication with this matrix. This is also correct, but complications will be made, and so that to avoid complications, this number keep at its as it is, and this number multiply lastly. So equal to 1 upon 5. How multiplication? Sum of multiplications of rows and columns place to place. So first row, first column. For prepare first row, first column, and first row, second column. So place to place means 3 into 0, 0 plus minus 2 into 2, minus 4. First row, second column, 3 into 1, 3 plus minus 2 into 4, minus 8. So first row prepare, again same, by using second row we prepare the second row. So second row, first column, and second row, second column. So we take the multiplication of second row with two columns place to place. 2 into this 1 into 0, 0 plus 1 into 2, 2. Second row, second column, 1 into 1, 1 plus 1 into 4, 4. So equal to what? 1 upon 5 as it is. 0 plus minus 4 means 0 minus 4. 0 minus 4 is minus 4. 3 minus 8, what? 3 minus 8 means make the subtraction of 8 and 3. So values 5 and give the sign of largest number means minus. So 3 minus 8 minus 5. 0 plus 2, 2, and 1 plus 4, 5. So lastly multiply this number to all numbers of this matrix. So what we get? Minus 4 into 1 upon 5, minus 4 upon 5.
No more spending your energy and money on coaching classes, or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
So we discuss a very interesting problem. This is because A is given and B is given, and verify AB its inverse equal to B inverse into A inverse. So solving this problem, first we find the A into B, and then we take the inverse of this A into B. So what solution? A into B its inverse. So we take LHS equal to A into B inverse. A into B its inverse. So first we find the A into B and then take its inverse. So this is our A, this is our matrix B. So we put these two matrices at this place. So equal to, in the curly bracket, A is a matrix, first row 2, 3, second row 1, 2, into this matrix B means first row 1, 0, second row 3, 1, and it's a inverse. It's inverse. So we multiply this two matrix, place to place multiply, and then take sum. So equal to what? How multiplication? First row, first column. So 2 into 1, 2 plus this 3 into 1, this 3 into 3, 3 into 3, 9. So finish the first row, first column. Again first row, second column. What? 2 into 0, 0 plus this 3 into 1, 3. 3 into 1, 3. Again same for second row. So second row, first column, second row, second column. So 1 into this 1 plus this 2 into this 3, 2 into 3, 6. Again second row, second column. So 1 into 0, 0 plus 2 into 1, 2, and it's a inverse. So here is the inverse equal to what? This 2 plus 9, 11, 0 plus 3, 3, 1 plus 6, 7, and 0 plus 2, 2. It's a inverse. How can find the inverse of this matrix? Also by using adjoint method. So what is the formula for A inverse by adjoint method? A inverse equal to 1 upon determinant of A into adjoint of A. Always box the formula or given the number to the formula. So we give the 1, but condition what? Determinant A is not equal to 0. Determinant A is not equal to 0. So we check first determinant. So determinant of A equal to what? Determinant of A means determinant of this actually matrix. So determinant of 11, 3, 11, 3, second row, 7, 2, 7, 2 equal to what? How find the determinant? So this 11 into 2. So this is a 2 by 2 determinant, second order determinant. So we take cross multiplication. So 11 into 2, 22 minus 3 into 7, 21 equal to 1, and this is not equal to 0. This is not equal to 0, and therefore A inverse exists, and therefore inverse of this matrix is exist. Again we find the adjoint of this matrix. So for adjoint there are 3 steps. We find the minor of matrix A, means this matrix. We find the cofactors of this matrix, and lastly adjoint of this matrix. So first we find minor. So minor matrix equal to what? For this matrix, minor of matrix equal to what? Minor of matrix equal to, so we find the all minors of this number. Okay, so how minor is the determinant obtained by deleting row and column passing through that number. So here is a 11. So row and delete column and row delete. So what remaining 2. So determinant of 2 itself 2. So this is 2. Again minor of 3 half. So row column delete. So what remaining 7. So determinant of 7 itself 7. What is the minor of 7? Row column row delete. So what remaining 3. So determinant of 3 itself, and minor of 2 means row column delete. So 11, determinant of 11 itself. So this is a minor of this matrix. Again we find the cofactors of this matrix. So cofactor of matrix equal to cofactor of matrix equal to, what is the meaning of cofactors? Cofactors means this is a 2 by 2 matrix. So use a simple idea, no change, change by sign. So diagonal as it is and only change by sign. So minus 7 here minus 3. So cofactor of matrix. So what is adjoint? Adjoint of this matrix equal to transpose of cofactor of this matrix. So we take the transpose of this cofactor matrix. So first row 2 minus 7, second row minus 3 11. Transpose means convert the row into column. So first row become first column, second row become second column. So this is the adjoint of this matrix, and therefore LHS equal to what? LHS equal to 1 upon determinant A. Determinant A is 1. So 1 upon 1 is 1. 1 upon 1 into adjoint of this matrix, which equal to this matrix. So this is 2 minus 3 minus 7 11, which is equal to 1 upon 1 into every number of this matrix is as it is. So 2 minus 3 minus 7 and last 11. So this is LHS. In this manner we prepare also RHS. Also we find the RHS. So RHS equal to B inverse into A inverse. B inverse into A inverse. So first we find the A inverse and B inverse, and then we take the product of these two inverses with each other. So for finding A inverse and B inverse, first we use the same method, adjoint method. So by adjoint method, what formula? A inverse equal to 1 upon determinant A into adjoint of A, and condition is that determinant A is not equal to 0. So we check this condition first, and then we find the adjoint of A. So determinant A equal to determinant of A means this is a given matrix. So determinant of this matrix is a between two column. So 2 3 first row, 2 3, second row 1 2, and this is a second order determinant. So only take the cross multiplication. 2 into 2 4 minus 3 into 1 3, 4 minus 3 1, which is not equal to 0. The 1 is not equal to 0, and therefore determinant A is not equal to 0, and therefore A inverse exists. Again we discussed the how find the inverse of this matrix A by adjoint method. So we follow the 3 steps: minor of matrix A, cofactors of matrix A, and last adjoint of matrix A, means cofactor transpose of cofactors of matrix A. So here minor of A equal to matrix A equal to what? Minor means determinant obtained by deleting row and column passing through that number. So what is the minor of this number 2? So delete column and row passing through this number and take the determinant of remaining number. So determinant of this 2 itself number 2. Again minor of 3 what? Delete row and column passing through this number 3. So what remaining? 1. Determinant of 1 is itself 1. Again minor of 1 what? Delete row and column passing through this number 1. So remaining 3. Determinant of this 3 itself 3. Again minor of this 2 what? Delete column and row passing through this number 3. So what remaining? Only 2. So determinant of this 2 itself 2. So this is our minor of matrix A. By using this minor of matrix A, we find the cofactors of A. Cofactors of A what? What is the cofactors of A? Use the same idea. No change in the diagonal numbers, only change in the non-diagonal numbers by sign. Means these two as it is, only change in the 1 3 by sign. Here is a plus 1, so minus 1. Here is a plus 3, become minus 3. So this is cofactors of A, and therefore what is adjoint? Adjoint of A equal to what? Transpose of these cofactors of A. Means transpose of this matrix, transpose of 2 minus 1 as it is, minus 3 2. So what is the meaning of transpose? Transpose means delete. Transpose means convert the row into columns. So first row become first column. So 2 minus 1. Second row become second column. So minus 3 2. So this is our adjoint, and therefore by using this formula, A inverse equal to 1 upon determinant is 1 upon 1 into adjoint of A, means adjoint of A, and therefore A inverse equal to this adjoint of A means this matrix 2 minus 3 minus 1 and 2. Similarly, we find the determinant of this matrix B, determinant of this matrix B, because we want to find also B inverse. So for finding B inverse also formula same by adjoint method. What happen? B inverse equal to 1 upon determinant of B into adjoint of A. Adjoint of B here is the B matrix, so adjoint of B. So condition is that this determinant of B is not equal to 0. This determinant of B is not equal to 0. So we check this. So determinant of B equal to, so what is the B? This is a matrix B. First row 1 0, second row 3 1. So first row 1 0, second row 3 1. So again this is a second order determinant. So same idea use, we use the idea of cross multiplication. So 1 into 1 minus 0 into 3 0 equal to 1 minus 0 1, and which is not equal to 0, and therefore determinant of B is not equal to 0, and therefore B inverse exists. B inverse exists. Similarly, we find the adjoint of B by using adjoint method. So again we discuss the 3 steps: minor of matrix, cofactors of matrix, and transpose of that cofactors of matrix. So minor of matrix B equal to, again what we discuss direct, minor of 1, what, row column delete, what remaining only 1. So 1 take as it is. Again this minor of 0 what, row column delete, so only 3. And minor of 3 means 3 passing a row passing through 3 and the column passing through 3 delete, so only remaining 0. Again minor of 1 means delete row column passing through this number, so remaining only 1, so 1. So this is a minor of B, minor of B. Same we find the cofactors of B, cofactors of B. So what is the meaning of cofactors? Cofactor means this is a 2 by 2 matrix. So what is the idea? No change in the diagonal numbers, change the non-diagonal numbers by only sign. So 1 1 as it is, this plus 3 become minus 3, and this 0 become minus 0, means always 0. So we find the again adjoint of B by using this cofactors. We find the adjoint of B. So what is the adjoint? Adjoint is nothing but transpose of this cofactors. So equal to transpose of this matrix, means 1 minus 3 0 1. So what is the transpose? Transpose means convert the row into column. So first row become first column. So 1 minus 3. Second row become second column. So 0 1. So this is adjoint of B, and therefore A inverse equal to B inverse equal to what? What is B inverse by formula? B inverse equal to 1 upon determinant B. But what is determinant B? Value of the determinant B is 1. So 1 upon 1 into adjoint of B, and therefore adjoint of B means this matrix. So B inverse equal to 1 0 minus 3 1, and so that we find the RHS. What is RHS? RHS equal to B inverse into A inverse, means this B inverse, this is also A inverse, here A inverse, here B inverse, and we multiply both. So B inverse 1 0 minus 3 1, 1 0 minus 3 1 into A inverse. What is A inverse? A inverse, first row 2 minus 3, second row minus 1 2 minus 1 2 equal to, so we make the multiplication by place to place. So first row, first column, 1 into 2 plus 0 into minus 1 0. Again first row, second column, what happened? 1 into minus 3 0 into 2 0. Again second row, first column, minus 3 into 2 minus 6 plus 1 into minus 1 minus 1. Second row, second column, minus 3 into minus 3 plus 9, 1 into 2, so plus 2. So this is equal to what? 2 plus 0 2 minus 3 plus 0 minus 3 minus 6 minus 1 minus 7, and 9 plus 2 11, and this is equal to our LHS. LHS is also 2 minus 3 minus 7 11, and therefore AB inverse equal to B inverse into A inverse is verified. So this is a true result. So in this manner we discuss very interesting this problem. Also we discuss more problems in our next session.